Calculating fertilizer application rates is actually a lot sexier than it sounds. It's definitely going to impress your future employers, maybe your significant other, and it's a great real-world application for math that you can tell your kids about. Fortunately, the math is pretty easy. A lot of folks are intimidated, but the formulas are pretty simple, multiplication and division, as long as you have an understanding of what those three numbers on that fertilizer bag mean. Say it with me, nitrogen and good. So that ratio in a fertilizer is what we're going to use to calculate all different types of fertilizers. And we need to know this because if we don't, we're going to give our plants way too much fertilizer, which can burn them, or not enough, which can starve them. And who wants to be that guy? Regardless of the type of application or the type of fertilizer you use, knowing that those ratios, those numbers are a percentage of the fertilizer, that particular nutrient that's in the fertilizer, is where we begin our calculations. Now, depending on the crop you're growing, you might use a dry application, which is fertilizer that's mixed into the soil. This could be organic or inorganic. You may have used these slow-release Osmocote little pellets that are time-release that you mix into soil, or perhaps you've used a spreader to broadcast dry fertilizer onto a lawn. We'll talk a lot more about turfgrass applications and weights and calculating those based on the percentages in a later week. Liquid applications come in a lot of different forms. You might have mixed one to establish a tree in a starter application or a spray through a foliar application. But today we're going to be talking about fertigation. And fertigation is basically the use of fertilizer that's injected into irrigation water so that you're not having to take your watering can and add your tablespoon or ounces of fertilizer and keep doing that over and over again. Fertigation allows you to add fertilizer each time you water, which is great in larger greenhouses or farm applications. So fertigation can be very simple. You might have seen the little Miracle-Gro feeders back in the day. You mix a little bit of fertilizer in the bottom, and then the water that gets in there creates your nutrient stock solution, so that based on the dial or the ratio of the application, how much you want it diluted, essentially, each time you water, that's applied when you spray. So that's a very simple example. Another is if you have sort of this tank, you've got irrigation, you've just got water up there through a cistern, or you filled the tank and it's 100 gallons, and you need a certain concentration of fertilizer, parts per million, which we'll talk about, maybe 100 parts per million. So you've added about 13.5 ounces to that tank, and when that tank is empty, you're filled up with water, and then add your fertilizer again. But a fertigation system uses an injector. Here's a very simple example where it pulls from a stock solution, that's a particular concentration of fertilizer, and then applies it at a rate. So it dilutes it over what the ratio that you want each time you water when you turn on the hose. So there's a very simple example. A little bit more complex. A greenhouse might have different rates for different plants or different crops or different zones, and so those can be set and even regulated using a control system within the greenhouse. So very different levels of complexity when it comes to the fertigation system you use, but essentially it comes down to those three numbers. Now we know there's other secondary macronutrients and micronutrients in your fertilizer, but those three numbers, the N, the P, the K there, we're going to pay attention to calculate rates. So why do we use parts per million? If you look at the fertilizer analysis, here my fertilizer, my N is 10% of the overall weight of the fertilizer, or 30 for phosphate, and my 20% here is my potassium. That can vary from fertilizer to fertilizer. Remember, the other one was 14%, 3%, 14%. So parts per million are effective because it allows us to mix up fertilizer independent of the analysis, whether it's 14-3-14 or 15-0-0 or 20-20-20. Parts per million basically mean that within, if I were to look at this as like little blocks, and there were 1 million blocks in there, then 1 part per million, right, 1 ppm, would be one of those blocks. If I thought about that in terms of fertilizer, if this was liquid, right over here, and I had 1 million parts, and 200 of those, right, 200 of those were the fertilizer, I'd have 200 parts per million. And a lot of fertilizers, the reason why they add this artificial coloring, that bright blue, is often because we can see dilution, right? If I had 500 parts per million, it might be a very dark blue versus 1 part per million, where it might not even be, it'd be imperceptible, it might be clear. And so parts per million allow us to look at the concentration of fertilizer within a solution. So the fertilizer is the solute, and then generally the water is the solution. So we're talking about the strength or concentration of a fertilizer. In an injection ratio in a fertilizer injector, right? So here I've got my tank that might have my solution, my stock of my fertilizer mix at a particular concentration. Maybe it's 200 parts per million or 100 parts per million. And then an injection ratio allows me to calculate how much of that stock solution, that's a certain concentration, is being diluted into the water I'm irrigating. So for example, a 1 to 100 injection ratio would deliver 100 gallons of fertilizer solution per 1 gallon of concentrated stock. So the formula itself is actually pretty easy in order to calculate the volume of the stock solution, the nutrient solution that you need to add to your fertigation system. And there's actually a lot of charts and tables that would probably come with most fertigation systems to help you make those calculations. But it's important to understand where those numbers come from and why. Essentially, the formula is just the parts per million of the nutrient concentration you want. So for example, if I read my fertilizer and it says for the stage of plant growth that my plants are in, I want to add 250 parts per million. So I would multiply my 250 parts per million times the ratio of dilution of my fertilizer injector. So if it was 1 to 200, I would simply take 250 and multiply it times 200, and that would give me 50,000. Then I take that number and just divide it by the percentage of nitrogen in the fertilizer I've chosen and multiply by a constant. So for example, if my fertilizer was 15, 15, 15, I would have the number 15 as my percentage of nitrogen. And so the last variable I would use is a constant. And now your constant is actually based on the measurement. If I have a fertilizer, so say I have my 15, 15, 15 fertilizer that is asking me to add in ounces, right, I would use 75. If I'm looking at pounds, I'm going to use the constant of 1200, and grams, I'm going to use 10. So this is going to vary based, again, on the fertilizer type you're using. So that all is going to be found, again, in your fertilizer analysis here, so you'll know what that is, and you'll also know the ratio. So you actually have all of these variables. I want 250 parts per million. I'm using a injector ratio of 200, so that top number, that numerator, is going to be, let me see if I can write on here. Let's see that, maybe 200, whoops, come back, 200, I'm sorry, I said 250, didn't I? So 250 parts per million times, so my ratio was right, 1 to 200. So I'm just going to use that 200, the larger number, and that's going to equal 50,000. So my numerator, right, that's a comma, I've solved for, and now I just have to figure out what I divide this number by. I know that my fertilizer, let's say it's 15, 15, 15, so I'm using the percentage of nitrogen. And this one's going to have me measure in ounces, so my constant will simply be 75. So I do that math, and I end up with 1125. And I'm going to bust out my calculator for this one, but I'm just going to divide 50,000, right? So we're here now, 50,000 by, where's my calculator? $50,000 by 1125, and you can't see my calculator, but that's going to give me about 44.5 ounces. Keep in mind that unit is going to be based on your constant. So if I've used pounds, right, my unit will be in pounds. So I'm going to end up with, when I divide 50,000 by 1125, I'm going to end up with about 44.5 ounces of this particular fertilizer, right, my 15, 15, 15, that I'm going to add to create my volume in my actual fertigation tank here. So this means that I can play around with each of these 4 variables now that I know what they mean. If I need to make a stronger concentration of fertilizer because of the stage of growth that my plants are in, this number would change in the numerator. If I had a different rate of application, so I went from 1 to 100 to 1 to 200, this would also affect the number in my numerator. If I changed fertilizers, I know how to calculate that. If I have a fertilizer that has lower amounts of nitrogen in it, that's going to impact, right, my denominator here, and therefore change the amount of fertilizer that I would have to add to create my stock solution.